Hello everyone, and welcome to today's chem lesson. Today we are going to talk about electrons and where they go in the atom. When we talked about Bohr's model in the past, we talked about how the protons and neutrons hang out in the nucleus, and out here in these electron shells is where the electrons are. But we can't just assign electrons wherever we feel like. We have to be careful where we put our electrons because there's only a certain amount of electrons that can fit in each of these shells. And the way that they will assign themselves into these shells is very purposeful. And this is the whole idea of an electron configuration, and something that we will work on using the reference table for a little bit of time here. Right, if I were to pull up a picture of Bohr's model, we could see that these shells are concentric circles, with each one bigger than the one that came before it. Right, shell 3 is much bigger than shell 1. If I put shell 4 in here, shell 4 is much bigger than shell 3. Right? Each one gets bigger than the one before it. And so, when we think about this, each shell should be able to hold more than the one that came before it. Right? And there is a very specific amount of electrons that each of these shells can hold. There are a total of 7 possible shells for an electron, or for an atom. The first 3 are here. 4 would be this circle out here, but 5, 6, and 7 are actually pretty much the exact same size. There's not a large gap like there is between shells 1 and 2, 2 and 3, and 3 and 4. Right, shells 4, 5, 6, and 7 are all pretty close together in terms of size. Now, let's talk a little bit about these specific numbers of electrons. Right. We've got shells 1, 2, and 3. Let's put 4, 5, 6, and 7 all back here. Now, each one of these shells has a maximum number of electrons it can hold. The first shell can hold a total of 2 electrons. Alright, only 2 electrons fit on this shell. Any more, and they get pushed out to the second shell. Second shell can hold a total of 8 electrons. Third shell, 18. The fourth, fifth, sixth, and seventh shells, because they're all pretty much the same size, can all only hold 32. Right, so no matter if you're in the 5th shell or the 7th shell, the maximum number of electrons that you could fit there is 32 electrons. And so, electrons will fit in to these shells in order from the closest to the nucleus, and then move out, and then move out, and then move out. Right? They will fill in as close to the nucleus as they can, and then take the second shell if the first one's filled, the third shell if the second one is filled, and so on. Now, remember, the Bohrs model is a simplification of something that's actually happening, right? The quantum mechanical model is the real model of the atom, and this is a close approximation. It is not 100% accurate. And so when we look at the periodic table in a second, we will see that there's a little bit of a disconnect. When you are tasked with making an electron configuration, the most important number, or the two most important numbers, are going to be the ones in the bottom left and upper right corners. The bottom left is the atomic number, which is equal to the number of protons. And the number in the upper right-hand corner is the charge, which is equal to the number of protons minus electrons. If you have a neutral atom, if protons minus electrons equals 0, then the number of protons and the number of electrons is the same. And so if I look at beryllium here and I say, okay, it has a total of 4 protons and also 4 electrons, I need to put my electrons into my shells in the right order. This is the most common way you'll see shell configurations drawn out, right? Nucleus and then these semicircles to represent the shells instead of having to draw the circle that goes all the way around. So looking at this, I've got 4 electrons that I need to put in. 2 go in the first shell because that's the maximum that that shell can hold. Right? We're going to fill as close to the nucleus as possible. We still have 2 left, so they're going to go in the second shell. We can do the same thing with silicon over here. I've got 14 protons, charge of 0, which means I also have 14 electrons. I've got to put 14 electrons in these shells. I want to start with the shell closest to the nucleus, which can only hold 2. Then I've still got 12 electrons left to put. Only 8 of those fit in the second shell. I still have 4 electrons left to put. And so you fill from the closest to the nucleus moving outwards. What about arsenic? Can you fill the 33 electrons that arsenic has? Arsenic has 33 electrons. So, I'm going to start by putting 2 in the first shell. I've got 31 left. 8 in the second shell. I've got 23 left. 18 in the third shell. I have 5 left to put right there. Alright, nothing goes in this last shell, but we fill our shells up before moving on to the next one. Right, everyone wants the front row seats. When those are taken, we take the second row seats. And when those are taken, we take the third row seats. $18 in the third shell. Right, so the question is why 18 in the third shell? We need to fill a shell up to the maximum before we can go on. The first shell can maximum hold 2, second can maximum hold 8, third can maximum hold 18, 4, 5, 6, and 7 can maximum hold 32. And so we're filling these rows, right? If we put 2 in here, that leaves us with 31 electrons left. Only 8 of those fit in the second shell. Right, and then, because there's still 23 left, we put 18 in the third shell, which is the maximum amount that that third shell can hold. And then we only have 5 left, and those last 5 go in our fourth shell. So yeah, the summary is you're filling each shell, and then the remainder goes in the last shell, right? If there's overflow, right here, 2 fit in the first, and the remainder fit in the second. Here, 2 fit in the first, 8 fit in the second, the 4 remainder went in the third shell. Here, the 2, 8, 18 all filled up their shells, and the remainder went in the fourth shell. Let's take a look at the periodic table for a second. Right, if I were to zoom in, which I know I can, thank you, right there. The electron configuration for these things is here on the periodic table. Right, it shows us the configuration. 2 electrons in the first shell, 8 electrons in the second shell, 18 electrons in the third shell, 5 electrons in the fourth shell. Same thing for silicon, which we just did, 2, 8, and 4. But the periodic table is not always going to line up with what you expect the electron configuration to be. Right, for example, here, 2, 8, 18, 18, and then 8, instead of this shell, which can hold a maximum of 32, containing all 26 of these electrons. The electron configurations on the periodic table are always correct. The electron configurations on the periodic table are based on the quantum mechanical model. Right, the model that is more advanced than the shell model. And so when you see something like this, 2, 8, 18, 18, 1, instead of 2, 8, 18, 19, that's okay. This is the correct configuration, and it uses information that we are not looking at when we look at just the shell model. Right, so the electron configurations are given to you on the periodic table, and they're going to look similar but not always the same to the ones you make yourself. Now, let's do some multiple choice practice. Which one of these is correct? Which one of these is correct? A on the left, B on the right. Which one of these is correct? A is the correct choice here. The first shell can hold 2. The second shell can hold up to 8. So if I have a total of 8 electrons to put in, 2 in the first, 6 in the second. No remainder for the third. Right here it's 2 in the first, 2 in the second. But this can hold up to 8. So these 4 should be in here, the second shell. You do not have to fill a shell, right? It's a maximum of 2 in the first, 8 in the second, 18 in the third. Why is there a third ring if there are no electrons? That's just the way the model gets set up. You'll see that sometimes. You don't always have to draw it, but you can for any atom. Put all 7, even if a bunch of them are zeros. The shells don't go anywhere. Right, these are just distances from the nucleus. These are just borders. Right, there's no big wall you have to pass through to go from New York to New Jersey. It's just a border on a map. Right, these are just specific distances from the nucleus where electrons can hang out. So you can draw them even if there's nothing in them, or you cannot draw them, or anything in between. And I can put just 2 of them if I wanted. Alright, let's try this one. Which one of these is correct? A on the left, B on the right. Here again, A is the correct answer. And the reasoning here is actually because of this number. The first shell can hold a maximum of 2. You will never have 3 in the first shell. Right, this could never happen, making it incorrect. 2 in the first, up to 8 in the second, up to 18 in the third. Right, filling in your early shells before moving on to your later shells. One more. Which one of these is correct? B is the correct answer here. And again, you have a total of 10 electrons, 2 in the first, 8 in the second, nothing in the third. You want to fill the second shell before you move on to the third shell. We are going to talk about when this happens, because it does happen. We'll talk about when and why this happens in our next video about ground state and excited state for atoms. But this is the correct electron configuration here on the right. And with that, I'm actually going to transition us over to our Zoom meeting for questions, comments, concerns, and attendance. And I will see you there.